This video is on how to write electron configuration using the short form or noble gas notation. You will need to have your periodic table out for this video, so make sure you pause and get that if you need to. So you have in your notes this diagram, the alphabet diagonal rule, like you've seen before, and we use this when we did the long form. So on your notes, you might want to draw in the diagonals again. It's good practice. The point of this video and this type of notation is taking those long electron configurations that we were writing before in the last video and now writing them in a shorter way. So this is faster, shorter. You are going to have to know both, though, for the test, both the long form and the short form that I'm going to show you in this video. So quick refresher, this chart right here is going through the diagonal rule, which is the lowest to highest energy levels. And I want you to remember that an S sublevel at most can have 2 electrons. A P sublevel at most can have 6 electrons. D at most can have 10. And F can have 14. So just a reminder of that. So this noble gas notation, all right, we're going to have to find the highest numbered noble gas that comes before the element. So we need to know what our noble gases are. So on your periodic table, the noble gases are column 18, or the column all the way to the right. And remember, columns are up and down. So these, I'm going to outline them, are your noble gases. And if you want, you can label them on your periodic table right now, or we'll do that in class. So what you're looking for is the element with the noble gas that is closest to it, atomic number-wise, but not higher than it. So for example, comes before the element. So for example, if I was looking at, say, carbon right here, the noble gas closest to it without going over would be 2. Atomic number 2 would be helium. If I was looking for, let's say, the noble gas to use for, let's say, yttrium right here, Y, I'd have to look at the row above it and be krypton right here. So let's see, you want to put that noble gas in brackets. Now, you need to make sure brackets are not parentheses. Brackets are the little square ones, these guys. And you'd put the noble gas inside. So, for example, if it was helium, you'd write helium, and then you'd put brackets around it. That represents the electron configuration for that noble gas. So, equals electron configuration. Oops, sorry about that. There we go. For that noble gas. Okay, so then to figure out the remaining electrons, you're going to start with the S, so the S sublevel, for the row that the element lives in. So as I do a couple examples, this might make more sense. So let's do, to start, aluminum. So I'm going to go back to my periodic table here, and I'm going to see that aluminum is right here. So the noble gas I would use for this would be neon. So I'm going to write neon in brackets. So that represents the whole electron configuration for neon, which has 10 electrons. Now we have to get to 13. So this is, oops, wrong way, sorry. This is 10 electrons. So where do we start after this? We can't start with 1s. That's already been done with neon. So what we need to do is we need to look at the row that aluminum is in. So we've got row 1, 2, 3, and that's where we find aluminum. So we start with that row of 3, and we label it S. So we're going to start with 3s, and we know that S can hold 2. So now we're at 12 electrons. After 3s comes 3p, and we only need 1 more to get to 13, so it would be 3p1. So this is the shorthand. So this is much shorter, you can see, to write, especially with some of those ones on the bottom of the periodic table. So let's do another one. Let's do scandium. All right, so let's find that on here, right here, number 21. So the noble gas we're going to use for this one would be argon. There we go. So argon is right here, so 18. So argon is 18, and scandium is in row 4. So I'm going to write AR in brackets. And then I'm going to start with row 4, and we always start with S. So argon was 18 electrons, and we're trying to get to 21. So 4s2, so now we're at 20. And then after 4s, if I look at my diagonal, after 4s, we'd go to 3d. So it's going to be 3d1 for scandium. So argon is 18 plus 2 plus 1 is 21. All right, so another one. Let's do barium. So barium is right here, 56. So the noble gas we're going to use is Xe, which is xenon, with 54. And then barium is in row 6. So I'm going to write xenon in brackets. So that's those 54 electrons. And then I said it's in row 6. And 54 plus 2 is going to be 56. So 6s2, right? This is 54. Barium has a total of 56. All right, one more. And if you want to try this on your own, you can pause the video now and then watch it to see how you do. So Pb is lead. So if I go down, let's see, lead is right here. So 82. So we're going to have xenon again, 54. So lead is also in row 6, just like barium. So I'm going to write Pb, I'm going to write xenon in brackets. Okay, so that's my 54. And then we're going to come with 6s2. So now I'm at 56, like we just had with barium. But after 6s, we need to go to 6s. We're going to go to 4f. And 4f, remember, f can hold 14. So I'm going to write 4f14. Okay, so I'm not there yet because I need to get all the way to 82. So 54 plus 2 is 56. Plus 14 is going to be 70, but I got to get all the way to 82. So after 4F comes 5D. So 5D, D can hold 10. So 5D. So now I'm at 80. And then, oops, wrong way, sorry. And then after 5D comes 6P. And if I go back down, I'm where I needed 82. So my 6P is going to come here, is going to be 2. So these will now add up to my 82 electrons for lead. So that's noble gas notation, or short form. We will do more examples and discuss your questions in class.